All right, so let's move on to example 1. How do you go about graphing the hyperbolas? I started with a nice friendly one since you guys haven't seen them before. This one is centered at the origin. I can tell because it doesn't have anything except squared terms. So similar to the ones we've done before, but we're going to skip the step with completing the square. The first thing we want to do is get it to look like our values up here. We need there to be an equal to 1 on the right-hand side. So I'm going to take and divide my whole equation by 36. 4 over 36 would reduce down to 1 over 9, and 9 over 36 would reduce down to 1 over 4. And 36 over 36, very purposefully, is equal to 1. Now I can use that equation against the standard form to figure out a whole bunch of really important points. So for example, I know my center is at the origin. My vertices, right? I'm going to pull that information from here. I can tell just by looking at the equation that because y squared is the positive, I'm subtracting x squared, that this equation, or sorry, this hyperbola is going to open up and down. That makes my a value equal to 3 and my b value equal to 2. So now I've got to show you guys what to do with that. So let's make a nice sketch centered at the origin. So here's my center. And this is how it works. We are going to use that a value of 3 in the direction of the y-axis. So counting from the center, 1, 2, 3 up, right, because it's y's, and counting from the center, 3 down. And because y is my transverse axis, those two coordinates are actually the coordinates of my vertices. So we'll go ahead and use that. We've moved over 0 and up or down 3. The b value isn't going to show up on my graph of my hyperbola, but I'm going to use it to help me create sort of the distance and the opening here. So for the b value, notice b is associated with x, so I'm moving in the x direction, 2 units in either direction. And we create this little box. It's not really part of the graph, but we use it as our guideline. So I'm going to draw these parallels and create a rectangle that would be 2a high and 2b wide. And then you don't need a ruler, but I'll use one here to make my notes look really nice. I'm going to draw the diagonals of that rectangle. These are going to set me up so that I have a nice idea of how open my hyperbola is. Okay, so these are my asymptotes. And let's see. Now I'm ready to sketch in my hyperbola. My vertex, right? I know it opens up and down. I found my vertex, and I'm just going to sketch it so that my hyperbola opens and runs alongside those asymptotes. And I'll do it again down here. It opens up and runs alongside the asymptotes. So the green line is essentially like an imaginary line, but it's controlling the opening, right? Just like we use the latus rectum on the parabola to get an idea of sort of how wide this thing was. We just sort of sketch in the rest. You don't need to find 4 more points or something like that. Just find the vertex, sketch your rectangle, sketch your asymptotes, and then go ahead and sketch it in so that it looks like it's riding alongside the asymptotes. So let's double check. We found the center, we found the vertices. We are missing the foci, right? So that's the next thing we need to do. My foci should be inside of, right, inside of each of those bowls. So there would be 2 of them. And remember, I'm going to calculate my c value. My distance from center to foci, or to each focus, would be c squared equals a squared plus b squared. So here, c squared is 9 plus 4, or c squared is 13. Right? C then would be like a plus or minus 13, or root of 13. And so that tells me that my foci, right? Imagine I'm counting from the center, right? I want to go up to that focus. I'm still going to be aligned with the center in terms of the x. The only thing that's changing is that I want to go up to meet that focus. So my 0 from my center is still going to stay the same, my x-axis or my x value. But I'm going to take 0 and I'm either going to add to get up or subtract to get down. So plus or minus the root of 13, and that would give me the location of my foci. And the last thing that it has here is the equation of the asymptotes. Now, there are some formulas, and I'll show you, they're on the back side of your note sheet. But honestly, if you can find the equation of a line, you can find the equation of the asymptotes just by remembering that, which is a basic Algebra 1 concept. Please don't try to memorize the formulas. You'll just confuse yourself, right? Think about what you need to know to find the equations of a line. You have y equals mx plus b form. Look at this equation, right? The box that you've generated using your a and your b are exactly going to help you with your slope. Because if I'm going to calculate rise over run, then from that center, from that origin, I'm going up 1, 2, 3, and I'm going over 2. So I know that for this particular asymptote, I'm going up 3 and over 2. There's my slope. And I can visually see that my y-intercept, that b value, is the origin. Gets a little trickier if your center is not the origin, but you could cope, you could handle it, right? What is the other equation? Well, if you wanted to draw the equation of that line, just think about it this way. You're going down 3 and you're going over 2. So you know that your slope should be negative 3/2 x and then plus 0. I don't necessarily want to memorize. If I have a good sketch, I can come up with those equations myself. It's so much easier than trying to memorize all the different scenarios for the different pictures. So there's example 1. All right, we're going to do another one, a little bit trickier. We're going to move our center for example 2. So head on over to the next video.